Hello everybody, this is Jeff Jeunesse and welcome to our 8th lab exercise in geoprocessing. This time we're going to take a look at Python code. I'm going to show you how to take tools that you've created and convert them to Python code. I'm going to show you how easy it is to open Python code and take a look at it, and how it's fairly friendly language. It's fairly easy to look into it and see what's going on, and it's really easy to edit. Then I'll show you how easy it is to run edited Python code even when you don't really feel like you're really a programmer yourself. And this will let you run tools in a more complex and powerful way, and maybe even make Python look fun to you and give you some motivation to actually learn it sometime. Okay, we're going to pick up where we left off in lab exercise 7. We created a model, we ran a model that produced this buffered area within our analysis region. So we want to take a look at our model to start with. So we go to the catalog. Remember, our model's in our default geodatabase. It's in our toolbox that we created in there, so we can just double click on this to open it up, and there's our model. Now we need to open the model. The way you open the model is you right click on it and do edit. Now a lot of people want to open it just by double clicking on it or right clicking and doing open, and that seems reasonable. But what happens is that ArcGIS Pro opens it up as if it were a tool ready to be run, and it's expecting you to run the model when you open it or double click. So it says there's no parameters being asked for. We just hit run, and maybe it'd run, maybe it wouldn't. But no, we want to actually open it up and edit it. So we got to right click, do edit. That gets our model open for us. Now we're going to export this model to Python code. Do that up here in the Model Builder tab. Come to this little Export a Model function. Click the little down arrow next to it. And we've got 3 ways to export it. We're going to export it to a Python file, which just makes an ASCII text file of Python code on your computer. It ends in a .py extension. We can open it up in any text editor. So I'm going to choose that. We have to choose where to save it. I'm going to put it where I've been putting everything else in these lab exercises, this lab demo folder. So I'm going to open that up. I'm going to call it jeffjeunessebuffer.py, hit save, and now we should have a Python text file in that folder. If I go to Windows File Explorer, I can go take a look in our lab demo folder, and sure enough, we have created it here. Now we want to open it up and take a look at it. We want to use a text editor to open this up, and all Windows computers come with a program called Notepad. Notepad is a fine program for this. We right-clicked on it and we went to Open with Notepad. It would open up in your most basic text editor program that Windows offers, and the code would look like this. This would work just fine. If this is what you have, go ahead and use this. I personally like a program called Notepad++. This is a program that is written by programmers for programmers, and it's a modified version of Notepad that's really better for programming tools. It's designed to restructure and re-symbolize all the text in a way that programmers really like to see. You can even open things, close little groups. It's a really nice programmer's tool, and it opens this exact same file. So I'm just going to demo this in here. If you don't have Notepad++ installed and you would like to have it installed, it's a free program. Just Google Notepad++. Really popular free tool out there, and it's really nice. All right, so here we are. We're looking at the Python code. Now, nobody's expecting you to read all this and intuitively understand the structure and routines of Python. But I would like you to notice a couple things. When you see a number sign, a pound sign, that means a comment in Python code. It means that the text following that is going to be ignored by the program compiler or the program runner. These are notes that programmers write to themselves to help them keep organized and know what's going on in the code. Now, there are 3 important ones here I want you to see, 3 important comments. This first process, select layer by attribute. The second process, the buffer analysis, and the third process, the clip analysis. You should recognize as these are the 3 tools that you just put into your model a little while ago. So we look closely at it, we could see that there's this function called ArcPy management select layer by attributes, and then everything after that, these are the parameters we set in that tool. So we made it a new selection, for example. Here was our SQL query, name equals Fry Park. In the buffer analysis, this ArcPyAnalysis.buffer is running the buffer tool in Python code. Here are the parameters we used. We made it a geodesic buffer. We made the buffer distance 0.5 miles, and then the clip. Now let's take a look at our two homework questions here. So for your homework, you're going to have to take this code, just copy it all, and you just paste it into your homework document. So I can see that you were able to successfully export the code. Second question for the homework is how specifically would we change this code to create a quarter-mile buffer instead of a half-mile buffer? And hopefully it's pretty intuitive. We'd run this code, but we would change this, right? We'd change this from 0.5 miles to 0.25 miles. All you have to do is type a little 2 in there, and it would rerun the tool using a quarter-mile buffer. So that's all that would take. Homework questions are handled. But let's continue on with the lab. I want you to see how you can edit this and actually rerun it yourself and start to get a sense of what you can really do with Python. So I'm going to close this Python window here. Let's continue on with the lab. This time we're going to export the model. But instead of a Python file, we're going to send to a Python window. This is one of the two ways that ArcGIS Pro provides you to run Python code. So I'm going to hit that. I'm going to close the model itself now. And here is the little Python window. This is also, you can undock it if you want. So here's the exact same code we're looking at. If we wanted to run it right now, we could, but it would give us a problem because there are a couple of areas where it's trying to create data that the data already exists. In particular, in this clip tool, see, we ran this clip tool where we were saving the output to be this file called rock project buffer, located in our default geodatabase. Well, there's already one in there. So first off, we're going to have to change that name. We're going to, otherwise the model would crash. So I'm going to just change this to rock project buffer 2. Next up, I want to run this at a quarter-mile buffer. So I'm going to change that value in the distance to a quarter-mile. Just to be safe, I'm going to change this intermediate data set name. It was named road buffer. I'm going to change it to road buffer 2 just to avoid any chance of running into data that already exists. All right, so all I did was change this value. I changed the name of the output. I changed the buffer distance, and I changed the name of the final output. All right. Now, I go to the, actually, you can put the cursor anywhere you want, but if you just hit enter, it runs the tool. And you see it's going to town. It's finished running now, so let's close this Python window, go back to our map, and look, we have a new quarter-mile buffer added to our map. Let's change the color so it stands out a little better. And there it is. The new quarter-mile buffer. We just ran it in code. And just to be clear, a lot of times people will run these tools. They don't even really care about the output so much. But by running the tool, you're able to generate the Python code that runs that tool, and you generate it error-free. So it's kind of an easy way to generate little code snippets. So I've used that method quite a bit. One thing that isn't in the lab exercise is how to get the Python code from a single run of a tool rather than from a model itself. And we just saw how to get the code from a model, right? You open up the model, you start editing it, you go to here, you export to the code. That's how you export Python code for an entire model. But how about if you've run a single tool recently? How do you get the Python code for that single tool? Well, that is back in the Analysis tab If you've run it recently, you can hit the little history function here. It'll show you the tools you've ran recently. So we ran a clip tool a while ago in an earlier lab exercise. I can right-click on this, go to Copy Python Command, and it copies the Python code into the computer memory. So if I went back to Notepad or Notepad++, in fact, let's just open up Notepad++ real quick. Make a new one here. And then if I right-click and do paste, remember it copied it to memory. Here is the Python code that runs that clip tool. So it was that easy to do. If I wanted to get the Python code that ran the buffer tool, I could do it as well. Copy Python command. Now this might be a good example. Just right-click on it, paste it in. Here is the Python code that runs the buffer command. If I want to maybe run it several times using making different buffers each time, I would paste it a few more times. All I'd have to do is change the values in here. Now I'd also have to change the output names. We don't want to be overwriting the same data set each time, so let me just change these as well. And now I have 5 lines of code all ready to run. So I can just copy this out. I would go to my Analysis tab in ArcGIS Pro, go to Python. These are the 2 ways ArcGIS Pro offers to let you run Python code. The Python window is a little simpler, so I'm just going to use that one. Here we are back in our Python window. You don't type up here. You type down here, the single line. But since I've copied all that to memory, I can just paste it in. Paste. Here are my 5 runs of the buffer tool. I just hit enter a couple of times and it goes to work. Okay, it says it's done. Close this. Let's check our geodatabase where it was writing all that stuff. Yep, here's our 5 new buffers that we created. It even added them to our map. So it was that easy. So copying and pasting Python code from a single run of the tool as well. Now, one last general comment on Python code. You see how easy it is to run within ArcGIS Pro, and you can do cool things, and that's what a lot of us do quite often. But you can also build kind of complex Python functions that can run outside of ArcGIS Pro. It uses ArcGIS's internal libraries, but ArcGIS Pro doesn't even have to be turned on. And people do this for tasks that need to be run regularly. So I have functions at the museum where I run them every night at 2 or 3 in the morning, and it does about an hour's worth of work. And it just runs independently of ArcGIS Pro. And it's another really useful use for Python code. All right, thanks so much, everybody.